All right, we're going to take another example here that allows you to work again with your 5 kinematics equations. So example 1.2.2 says, in a 100-meter dash, a runner starts from rest and accelerates to a velocity of 9.60 meters per second west in 4.20 seconds. Calculate the average acceleration of her displacement over that time. If she runs at that velocity for the rest of the sprint, what is the total time for her 100-meter dash? Okay, so again, let's look at defining all of our variables. Before we even start here, because the one direction we've given here is west, right? And she starts from rest, we're going to assume that the 100-meter is also in the west direction. So I'm going to say for this example that anything in that west direction for us is going to be defined as positive. Okay, so let's start by defining our variables. Well, if she starts from rest, we know that her initial velocity is 0 meters per second. Okay? And she accelerates and gets to a velocity of 9.60 meters per second. So that's going to be her final velocity. And because it's in the west direction, that's what makes me know that that velocity is going to be positive. Okay, and then the time that it takes her to do so is 4.20 seconds. Okay, so for A, we're looking at solving for her average acceleration to start over that point. Okay, so the average acceleration, remember, is just that change in velocity. So V final minus V initial all over that change in time. Because we don't have an initial velocity, we know it's 0 meters per second. So the average acceleration is simply just going to be that final velocity divided by that change in time. So our 9.60 meters per second divided by 4.20 seconds. If we type that into our calculator, what we end up with is 2.2857 meters per second squared is our acceleration. Okay, so that's the first thing they wanted us to solve for in A. They also want us to solve for her displacement over that time. Okay, that's what's actually going to help us solve for the total time that it takes her to run, because we need to know how far she runs over that time that she's accelerating to know how far she has to run to finish the race. Okay, so now we need to look at solving for that displacement. You could go ahead and use the acceleration that you just solved for when looking for it. If you do, I would recommend that you carry as many decimal places as you can and then just round to significant figures in your final answer. I would recommend, however, though, that you just use the variables that we've been given to start the problem. So we know we have initial velocity, final velocity, and time, and we're looking for the displacement of that object. So our kinematics equation that involves all of those says that the displacement of an object is equal to the final velocity, subtract the initial velocity, divided by 2, all multiplied by time. Time. And excuse me, I made a mistake. It's final velocity plus initial velocity divided by 2. Sorry, so the displacement is equal to the final velocity plus the initial velocity divided by 2 times that change in time. Again, we don't have an initial velocity, so really the displacement is just going to be equal to the final velocity of the object divided by 2 times that change in time. So again, our final velocity was 9.60 meters per second. We're dividing that by 2, multiplying that by, our change in time, which was 4.20 meters per second. Oh, sorry, 4.20 seconds. Time is in seconds. So 9.6 divided by 2 gives me 4.80 meters per second. Okay, and that is multiplied by our time of 4.20 seconds. When we plug that into our calculator, what we end up with is 20.16 meters. Right? Your seconds are going to cancel here, leaving you with just meters. So for part A, our final answers are the acceleration of the object, if we go to our significant figures, is going to be 2.29 meters per second squared in the west direction. And our displacement over that time is 20.2 meters in the west direction. Okay, and those are your final answers for part A. Okay, for part B now, we have to look at if she runs that velocity of 9.60 meters per second west for the rest of the race, what is the total time for her 100-meter dash? Okay, so for average velocity, remember, if she's not accelerating anymore, then we can now look at, using our formula that says average velocity is simply equal to the displacement divided by the change in time. Okay, we know what her average velocity is, and we have a way to determine what that displacement is, right? We know it is a 100-meter dash, and over the time she was accelerating, what you just solved for in part A was her initial displacement over her acceleration time. So if we subtract that displacement, then we know how far she has left to finish the race. So 100 minus our 20.16 is going to leave us with 79.84 meters. Okay. The reason I carry the 20.16 is I'm just going to carry the one that has more decimal places and round two significant figures in my final answer. Okay, so now we know the displacement of the object. We know the average velocity of the object. We're trying to solve for that time. So we want to isolate this equation for time. So time is going to be equal to the displacement of the object divided by that average velocity. So our displacement is 79.84 meters, and our average velocity was 9.60 meters per second. Okay, and that leaves us with 8.31666 repeating seconds. Okay, now it asks for the total time of her 100-meter dash. So this time here is only for that final 79.84 meters, right? Remember, we also had time for when she was accelerating. So her total time is this 8.3166667 seconds that we just solved for, plus that initial 4.20 seconds that she took while she was accelerating. So the total time for her to finish the 100-meter dash comes out to 12.516 repeating seconds. So the final answer for part B, if we look at putting it into significant figures, same as part A, it's going to be 3. The total time for her to finish her 100-meter dash was 12.5 seconds.